These mechanical monsters didn't just cut trees, they demolished entire forests in seconds. The 1980s unleashed the most savage timber beasts ever built. Machines with hydraulic claws that could rip, crush, and stack massive logs like toothpicks. No safety features, no mercy, pure raw power. Before modern tech tamed them, these 10 brutal fella bunches were the apex predators of the logging world. This is their untold story of destruction and dominance. Number 1. Timberjack 608. The Timberjack 608 stands as one of the most influential fella bunches ever built, especially during the rapid mechanization of logging operations in the late 1970s. Manufactured by Timberjack, the 608 was designed at a time when the forestry industry was aggressively moving away from chainsaw-based manual felling toward full-scale mechanical harvesting. What set the 608 apart was not just its cutting ability, but its overall balance of power, durability, and reliability in environments that destroyed lesser machines. At the heart of the Timberjack 608 was a Detroit diesel 6V53 engine, a two-stroke power plant legendary for its unmistakable high-pitched scream and near-indestructible nature. This engine was not fuel-efficient by any modern standard, but it delivered consistent torque and could operate for long shifts under heavy load. In remote logging camps, where downtime could cost thousands of dollars per hour, that reliability mattered more than anything else. Operators often joked that as long as it had fuel and oil, the engine would run, even if it was leaking both. The 608 was built on a tracked undercarriage, making it especially effective in soft ground, swampy terrain, steep slopes, and snowy conditions common in Canada and the northern United States. Tracks distributed weight evenly, reducing ground pressure and allowing the machine to work where wheeled fella bunches simply couldn't survive. This made the 608 a favorite for clear-cut operations in boreal forests and mountainous regions. The boom and cutting head design reflected 1980s priorities. Strength over refinement. Whether equipped with a shear head or an early disc saw, the 608 could handle medium to large diameter trees with confidence. The hydraulic system was straightforward and massively overbuilt, with thick hoses and simple valve systems that could be repaired in the field. Electronics were almost non-existent, which meant fewer failures in wet, cold, and vibration-heavy environments. Operator comfort was minimal. The cab was loud, hot in summer, cold in winter, and filled with vibration. But the visibility was excellent for its time, and experienced operators valued the machine's predictable handling. Many Timberjack 608 units logged tens of thousands of hours, and some are still operational today over 4 decades later. That longevity is the ultimate proof of why the 608 is remembered as a true brute of 1980s forestry. Number 2. Timberjack 618. As logging companies pushed into stands with larger trees and higher production targets, Timberjack responded with the Timberjack 618, a machine that took everything proven on the 608 and scaled it up. Introduced during the early 1980s, the 618 was designed for heavy-duty felling, where tree diameter, terrain difficulty, and daily output demands exceeded what smaller machines could comfortably handle. Like its predecessor, the 618 relied on Detroit diesel engines, often tuned for higher torque rather than speed. This made the machine exceptionally strong when handling large stems or multi-tree bunches. The emphasis was never on quick movements or finesse. Instead, the 618 was designed to apply steady, controlled force without stressing major components. In an era before load-sensing hydraulics and electronic engine management, this mechanical robustness was critical. The undercarriage of the Timberjack 618 was significantly reinforced. Heavier track frames, stronger rollers, and thicker steel plates allowed it to survive extreme abuse. Logging in the 1980s was not gentle. Machines were driven over stumps, rocks, frozen ground, and slash piles daily. The 618 absorbed this punishment with little complaint, which is why many contractors considered it a long-term investment rather than just a tool. Hydraulically, the 618 offered increased flow and pressure compared to the 608, allowing it to power larger cutting heads and booms. This made it particularly effective in old-growth and mature second-growth forests. Operators could fell, accumulate, and place multiple trees in a single cycle, improving efficiency for skidders and forwarders working behind it. The cab remained Spartan. Noise levels were extreme, and operator fatigue was common during long shifts. However, the machine's stability inspired confidence. Even when reaching far with a heavy tree, the 618 felt planted. This reduced accidents and increased productivity, especially in challenging terrain. In many regions, the Timberjack 618 became the backbone of large-scale logging operations throughout the 1980s. Its reputation for durability ensured that even as newer machines arrived, the 618 remained in service. Today, restored and rebuilt units are still respected for what they represent, a no-nonsense era when forestry machines were built to last, not to impress. Number 3. Hydroax 511. The Hydroax 511 represented a distinctly aggressive approach to mechanized felling during the 1980s. Built by Hydroax, the 511 was engineered with a clear priority: maximum cutting force, particularly when paired with hydraulic shear heads. This made it a dominant machine in hardwood forests, frozen timber conditions, and regions where disc saw maintenance was difficult or impractical. Unlike disc-based machines that relied on rotational speed, the Hydroax 511 used brute hydraulic pressure to sever trees cleanly. Its hydraulic system operated at very high pressures for the era, delivering immense closing force to the shear jaws. When the operator activated the cut, the tree fell decisively, often with a sharp crack that echoed through the forest. There was little hesitation, even in dense hardwood species like oak and maple. The 511's tracked undercarriage allowed it to work effectively in uneven and soft terrain. But the machine was known for running hot. Cooling systems were constantly pushed to their limits, especially during summer operations. Fuel consumption was high, but contractors accepted this trade-off in exchange for reliable production in conditions that slowed other machines. Structurally, the Hydroax 511 was extremely rigid. The boom, frame, and mounting points were designed to resist twisting forces generated during heavy shear cuts. This rigidity reduced fatigue cracking, a common issue in early mechanized logging equipment. Maintenance was frequent but straightforward, with easy access to major components. Operators respected the 511 for its authority. It wasn't fast, comfortable, or forgiving, but it did exactly what it was designed to do: cut trees relentlessly. In winter logging, especially in northern climates, the Hydroax 511 earned a reputation as a machine that could be counted on when chainsaws dulled quickly and disc saws struggled. Number 4. Hydroax 311. The Hydroax 311 was one of the most widely used and genuinely feared feller bunchers of the 1980s, and its absence from any serious list of brutal logging machines would be a historical mistake. Built by Hydroax, the 311 represented the company's move toward more refined but still brutally powerful mechanized felling, bridging the gap between early shear monsters and later high-production disc machines. Where the Hydroax 511 emphasized raw hydraulic violence, the 311 focused on controlled aggression. It was lighter, more agile, and faster in cycle time, yet still capable of handling large timber by 1980 standards. This balance made it extremely popular across North America, particularly in mixed hardwood and softwood forests, where versatility mattered more than sheer size. The Hydroax 311 was typically equipped with a high-pressure hydraulic shear head, though some later units ran early disc saws depending on region and timber type. The hydraulic system delivered immense clamping force, allowing operators to confidently fell hardwood species that would punish weaker machines. Cuts were decisive and clean, especially in winter conditions when chainsaws struggled and saw blades dulled quickly. Its tracked undercarriage gave the 311 excellent stability on uneven ground, moderate slopes, and soft forest floors. Unlike heavier construction-based machines, the 311 felt purpose-built for forestry. Weight distribution was better balanced, which reduced undercarriage stress and improved maneuverability in tight stands. Operators could reposition quickly without feeling like they were wrestling the machine. Structurally, the 311 was known for its rigid boom design and reinforced swing system. These areas were common failure points on early feller bunchers, but Hydroax overbuilt them intentionally. Fatigue cracking still occurred as it did on every 1980s machine, but far less frequently than on adapted excavator platforms. This durability made the 311 a long-term asset rather than a disposable tool. Operator comfort was still harsh. Noise levels were extreme, vibration was constant, and cabs offered minimal insulation. But compared to earlier machines, visibility and control layout were improved. Experienced operators could work faster, place bunches more accurately, and reduce skidder cycle times, something contractors noticed immediately. By the mid to late 1980s, the Hydroax 311 had become a cornerstone machine in mechanized logging operations. It didn't just survive the era, it helped define it. Many units worked well into the 1990s, and some remained productive decades later, a testament to how well the machine was engineered for real-world forestry abuse. The Hydroax 311 belongs on this list, not because it was the biggest or the loudest, but because it proved that brutality and efficiency could coexist, and that true forestry machines didn't need construction compromises to dominate the woods. Number 5. Pettibone 625. The Pettibone 625 represented a different philosophy in 1980s fella buncher design, one that prioritized mobility and speed without sacrificing durability. Built by Pettibone, the 625 was a wheeled fella buncher designed for regions where firm ground, flatter terrain, and longer travel distances made tracked machines inefficient. Unlike tracked units that crawled between cuts, the Pettibone 625 could move quickly across a logging site, reducing repositioning time and increasing daily production. This advantage was especially important in selective logging operations and thinning work, where machines needed to relocate frequently rather than work in tight, clear-cut patterns. The machine featured a four-wheel drive articulated chassis, derived from Pettibone's experience with industrial carriers and material handling equipment. This gave the 625 excellent maneuverability in dense timber, allowing operators to snake between standing trees while maintaining stability. Heavy-duty axles and planetary hubs were designed to handle constant shock loads from uneven ground and fallen debris. Power typically came from proven diesel engines that emphasized torque over speed. Combined with robust hydraulic systems, the 625 could operate large shear heads or early disc saws with confidence. While it lacked the raw ground pressure advantages of tracked machines, the wheeled layout allowed it to work efficiently in dry conditions without tearing up forest floors. Operator visibility was a strong point. The elevated cab provided good sight lines to the cutting head and surrounding trees, improving placement accuracy when bunching timber for skidders. Comfort, however, remained basic. Noise levels were high, vibration was constant, and climate control was rare. In the 1980s, many contractors chose the Pettibone 625 as a production-oriented machine for specific environments. It wasn't ideal for swamps or steep slopes, but in the right conditions, it could outperform heavier tracked competitors. The 625 demonstrated that wheeled fella bunches had a legitimate place in mechanized forestry, influencing later designs that balanced speed with strength. Number 6. Tree Farmer C5. The Tree Farmer C5 embodied the no-nonsense, overbuilt approach that defined many early mechanized logging machines. Manufactured by Tree Farmer, the C5 was designed for contractors who valued longevity and brute strength above all else. Everything about the C5 was heavy. The frame used thick steel sections with minimal weight reduction, the boom featured oversized pivot points, and the hydraulic components were chosen for durability rather than efficiency. This made the machine exceptionally resistant to structural fatigue, a common failure point in early feller bunchers. The C5 was most often paired with hydraulic shear heads, making it particularly effective in large-diameter timber. Its cutting cycles were slower than disc-based machines, but the closing force of the shear was immense. Trees fell cleanly, even in tough hardwood stands or frozen winter conditions. The tracked undercarriage provided stability and low ground pressure, allowing the C5 to work in uneven terrain without feeling unstable. Operators frequently commented on how solid the machine felt, even when handling heavy stems at full reach. Maintenance was straightforward but frequent. The machine lacked modern filtration systems and cooling efficiency, so regular servicing was essential. However, repairs were simple. Few electronics, accessible components, and robust mechanical systems made field fixes possible. Operator comfort was minimal. The cab was loud, vibration-heavy, and poorly insulated. But many operators accepted these conditions because the machine rarely broke down. In an era when downtime could shut down entire crews, that reliability was invaluable. The Tree Farmer C5 never aimed to be refined or efficient. It was built to survive abuse, and it succeeded. Many units remained in service well into the 1990s and beyond, earning the C5 a reputation as one of the toughest feller bunchers of its era. Number 7. John Deere 843. By the late 1980s, John Deere had firmly established itself as a major player in forestry equipment. The John Deere 843 was a clear signal that the company was no longer experimenting, it was committing fully to mechanized logging. The 843 combined Deere's engine expertise with purpose-built forestry engineering. It featured a powerful diesel engine designed for continuous heavy load operation, paired with a hydraulic system that offered smoother control than many earlier machines. This made the 843 easier to operate over long shifts, reducing operator fatigue. The tracked undercarriage provided excellent stability, while the boom geometry allowed precise placement of felled trees. Compared to earlier 1980s machines, the 843 represented a shift toward balanced design, still rugged and loud, but noticeably more refined. Operator visibility and ergonomics were improved, with better seat positioning, control layout, and cab visibility. While still primitive by modern standards, these improvements hinted at the future of forestry machine design. Durability remained a priority. Deere used heavy-duty frames and reinforced mounting points to handle the stresses of felling large timber. The machine was reliable, serviceable, and backed by Deere's extensive dealer network, an important factor for contractors operating far from logging hubs. The John Deere 843 bridged the gap between the brutal machines of the early 1980s and the more sophisticated harvesters of the 1990s, making it a landmark model in forestry history. Number 8. Caterpillar 227. The Caterpillar 227B feller buncher was Caterpillar's methodical entry into mechanized forestry. Built by Caterpillar, the 227B leveraged CAT's experience in construction and mining rather than reinventing forestry machinery from scratch. The machine was based on proven Caterpillar tracked platforms, emphasizing reliability and parts availability. In remote logging regions, this was a decisive advantage. Contractors knew that CAT parts and service could be sourced almost anywhere, reducing downtime. The 227B was not the fastest or most powerful feller buncher of its time, but it was dependable. Its hydraulic systems were conservative in design, prioritizing longevity over cutting-edge performance. This made it well-suited for steady production, rather than aggressive high-output operations. Structurally, the 227B was extremely durable. Thick steel construction and robust components allowed it to withstand constant abuse from stumps, rocks, and slash. The machine handled shear heads and early disc saws with confidence, especially in medium-sized timber. Operator comfort was basic but functional. Caterpillar focused on visibility, control reliability, and service access rather than luxury. The result was a machine that felt familiar to operators coming from CAT construction equipment backgrounds. The Caterpillar 227B proved that forestry could benefit from construction-grade engineering. While not as iconic as some specialized designs, it earned respect for its durability and helped pave the way for Caterpillar's later forestry-focused machines. Number 9. Franklin 170. The Franklin 170 is a lesser-known but deeply respected machine from the 1980s, especially among veteran loggers who worked in harsh, unforgiving conditions. Built by Franklin, the 170 carried unmistakable skidder DNA, and that heritage defined everything about how it performed in the woods. Franklin was best known for producing rugged cable and grapple skidders, and when the company moved into feller bunchers, it applied the same design philosophy: simple, strong, and nearly impossible to kill. Rather than designing a lightweight or specialized machine, Franklin essentially adapted proven skidder components into a felling platform. This resulted in a machine that felt extremely solid under load. The frame was thick, heavily reinforced, and resistant to twisting, an important trait when handling large trees at full reach. In an era when fatigue cracking was a serious issue across early mechanized forestry equipment, the Franklin 170 earned a reputation for structural durability. The Franklin 170 was typically paired with hydraulic shear heads, which suited its slow, deliberate operating style. It was not a high-speed production machine, but it delivered consistent performance in difficult timber. Hardwood stands, frozen winter logging, and rough terrain were environments where the 170 excelled. When the shear closed, the tree fell cleanly, without hesitation. Hydraulics on the Franklin 170 were straightforward and overbuilt. Flow rates were modest, but pressures were sufficient to deliver strong cutting force. The lack of electronic systems meant fewer failures in wet, muddy, and vibration-heavy conditions. Maintenance was frequent but uncomplicated, often performed directly in the forest. Operator comfort was minimal, even by 1980 standards. Noise, vibration, and heat were constant. However, many operators preferred the Franklin 170 because it felt predictable and trustworthy. Once positioned, it stayed productive with minimal downtime. The Franklin 170 never became a mainstream icon, but it earned respect as a workhorse machine, one that quietly contributed to the mechanization of logging during the 1980s without fanfare. Its legacy lies in its toughness and its ability to survive where more refined machines struggled. Number 10. Madill 122. The Madill 122 was not a refined machine, not a fast machine, and certainly not a comfortable one. But in the brutal logging environments of the 1980s, it earned a reputation as an absolute tank. Built by Madill equipment, the 122 reflected a distinctly Pacific Northwest philosophy of logging: massive timber, extreme terrain, and zero tolerance for mechanical weakness. Madill machines were born in British Columbia, where steep slopes, oversized old-growth trees, and relentless rain destroyed lightly built equipment. The 122 was designed with those conditions in mind. Weight was embraced, not avoided. Thick steel frames, oversized pins, heavy boom structures, and reinforced mounting points defined the machine. The result was a fellabuncher that felt planted and immovable, even when handling massive coastal timber at full reach. Power came from large displacement diesel engines tuned for torque rather than speed. The Madill 122 was never about quick cycle times, it was about controlled force. When paired with hydraulic shear heads, the machine delivered crushing cutting power that made short work of large diameter trees. In frozen conditions or dense hardwood, where disc saws could struggle or require constant maintenance, the 122's shear setup proved brutally effective. The tracked undercarriage gave the Madill 122 exceptional stability on steep slopes and uneven ground. This made it especially popular in mountainous logging operations, where wheeled machines simply couldn't survive. Operators could position the machine on grades that would have terrified crews in smaller equipment, then fell and place timber with confidence. Hydraulics on the 122 were simple, powerful, and overbuilt. There was little concern for efficiency or finesse. Flow rates and pressures were designed to keep working no matter how hard the machine was pushed. Hoses were thick, components were accessible, and field repairs were expected rather than avoided. Electronics were minimal to non-existent, which reduced failures in wet, muddy, vibration-heavy environments. Operator comfort was brutally basic. The cab was loud, hot, cold, and constantly vibrating. Long shifts were physically exhausting. But experienced operators respected the Madill 122 because it felt honest. The machine responded predictably, held its ground, and rarely failed catastrophically. In an era when downtime could shut down entire crews, that reliability mattered more than comfort. The Madill 122 never chased mass-market popularity. It was built for serious logging contractors working in the harshest conditions, and that niche defined its legacy. Even today, surviving Madill machines are spoken about with respect, often described as overkill. But in 1980s forestry, overkill was exactly what the job required. The Madill 122 earns its place on this list, not because it was elegant or advanced, but because it embodied the raw, unforgiving nature of mechanized logging before safety systems, emissions controls, and operator comfort softened the industry. It was pure industrial muscle built to dominate forests that offered no second chances. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.